Welcome, folks. We are here at the HortiCann 2019 show. This stream is brought to you by Keystone Technologies. Go to KEYSTONETECH.com, Greg.
Check them out.
Light made easy.
That's right.
Whoo! So we're here at HortiCann, Light and Tech, and we're joined by Kurt Leipmann of OSRAM Opto Semiconductors. We were just walking around the show and we bumped into them. And we said, we don't know enough about chips, Greg.
Yeah, we need to kind of deep dive on the LED chips.
And I don't think it has to be focused on horticulture. We can talk a little bit about horticulture, but the audience to this show doesn't totally care that much about horticulture. It's not all horticultural all the time, although we are here at the show.
So you guys actually make the LED chip.
Yeah, we are a manufacturer of the die as well as a packager of the material that goes around it.
How many companies are there that do that?
Oh, there's quite a few, probably too many than there should be at this point. But OSRAM Opto is actually the number 2 LED component manufacturer in the world. We are the dominant player in the automotive space. So pretty much any taillight you see on a car probably has one of our LED or multiple of our LEDs in it. But we also are one of the larger guys also for any of the other lighting spaces as well. We also do sensors, lasers, things like that as well.
Who's number 1?
Nichia.
Oh, dang it. All right. So what you guys had a graphic up there. How many different types of LED chips are there?
Tons. I mean, I just can't even count. We probably have more than we probably should have, but sometimes you make an LED specifically for an application if you have a large enough customer who's demanding something specific. And you know, if the demand makes sense, you make it, right? You may never use it again, but it made sense at the time to do it.
Your customers, are they fixture manufacturers?
Yes.
Are you selling direct to the fixture
So we sell directly to fixture manufacturers. That is the primary customer of ours.
And that's including automotive, horticultural, general purpose lighting, all over the world.
Signage.
Right. Signage, yeah.
Yeah.
Sure.
It's safe to say that not all chips are the same because there's so many of them.
Correct, yeah.
So what makes a quality chip versus a non-quality chip?
I would say it's the R&D that goes behind it. A lot of the LEDs that are out there, they're actually just packagers. So what I mean by that is they're buying dies from.
Yeah, you said a couple things.
Yeah,
you said a couple things at your desk. Or one grow. You said the word grow or something, or how you mix.
The crystal structure. Yeah, the growth of the LED. So there's actually
you said the word grow. That kind of
I mean it is. You're just like you grow like a sapphire, right? So a lot of times LEDs are grown on a sapphire substrate. So you grow it just like you would grow any kind of lab type gemstone or anything like that. So you're actually physically making the lattice structure of the molecules to create this dye that emits photons when you drive electricity through it.
And you're growing it.
You're growing it, yes.
You heard it first here, folks.
These guys are growing things.
You're growing it, and so that's a secretive process at OSRAM.
And everybody's got their own special secret sauce when it comes to creating that structure.
So that's where the research and development's really going on.
Yeah.
And that's where Shuji Nakamura made his white light thing, and that's
absolutely when he made that high powered blue dye that basically changed everything, because a white LED is actually a blue LED with a phosphor conversion on top of it.
What kind of environment is this that LEDs are actually grown in?
A clean room. Like I said, I've never been in
LED lights.
Are they grown by LED lights? I don't think you use LEDs to grow LEDs. That would be actually pretty interesting if you could do that.
Yeah. Kind of sounds like cannibalism or something,
or some kind of perpetual motion type thing that's defying the laws of physics, right?
So what is it that goes into the growth? Like, what's the process? You mix these chemicals, you sit them on the substrate, and off it goes.
If I told you I'd have to kill you, no. I actually honestly don't know. It's like I said, it's such a secret process that even employees of the company, when we go through, like, say, when you become new to the company and they show like the whole process, everything, it literally is like a box with a question mark in it. Just like, yes, things go in and an LED dye comes out.
Okay.
That's all we get to know. It's that important. It's that secret. And even if I probably got a chance to see it, I probably wouldn't understand it.
So the second thing you said that kind of was interesting to me was the packaging, right? So like that's where you're actually taking the crystals and you're embedding them into a chip, right?
Well, no. So when I say packaging, what I mean is the actual physical. When you think of an LED, you're actually talking about the entire thing. So in this picture here, we're talking about you've got what we call the substrate, right? So you have to mount the LED chip onto something, because you got to get electricity. You got to get electricity in and out of the chip, right? So you usually have to bond that to something. Usually you got a metal material that you put it on. You have
this is like a circuit board, isn't it?
Yeah, in a way, yeah. It's kind of like a mini circuit board that's encapsulated with either plastics or ceramic materials.
Sure.
And then so you bond everything together. You have to put these little gold wire bonds on there to get the electricity in and out of the different layers of the chip so that you can get the photons out. Then you usually have other things like protective coatings, so that in case of sulfur or anything that might be in the atmosphere, you don't want them to damage the part itself. And then usually you have like a dome over it, which helps a little bit with extraction as well as focusing where you actually want the light to go.
So making it a spot or a flood or whatever, right?
Yeah.
Let me ask you about this. So you talk about getting the photons out. Okay. Is there a limited amount of photons in every LED crystal chip or whatever?
That is a question I've never been asked before.
That's why I'm the host of this show.
Yeah.
Buddy.
So, I guess technically the answer is yes. It's based off of just how big the chip is. So usually when you talk about, like, say, a high power LED, usually the most common size is a 1 square millimeter chip. You'll also see 2 square millimeter and sometimes even 4 square millimeter. OSRAM offers all 3 of those sizes. The larger the chip, the more current you can throw through it.
Okay.
The more current you can put through the chip, the more photons that can be extracted.
So the bigger, the more photons that are in there.
Yeah.
Okay. Now, you know how they have these terms like L70 and this, or is that because the photons are running out?
No. Yes. No. Oh, that's good.
Because it's actually,
I'm going to use that one later.
No, but it's like one of those
photons,
things that you like. If you don't actually, if you know around the science, that's the way you get to put it. If you know around the science, but not about the science,
Right?
It's actually a logical question, although to someone who's a scientist, and it's like funny, right?
No, it is. I never thought of it that way. I mean, it's just degradation a lot in. I don't know if I know the exact mechanism what's causing the degradation. A lot of times the phosphors.
Well, electricity running through something affects it.
Yeah, exactly. I mean, while it's solid state, there's literally nothing physically moving. These quantum wells, I don't want to get too much into the science because, to be honest, I don't really understand it fully. They do degrade, and then what happens is when the electrons go through, instead of a photon flying out, they get trapped, they get lost, things like that. So over time, the chip becomes less and less efficient at converting electrical power into radiant power.
Did you listen to Greg? Are you hungry to say something here?
No,
give me that
dive. Yeah.
Okay. So did you listen to Dr. Mattsson's presentation, the keynote this morning?
Unfortunately, I didn't get a chance to.
Okay. So, but he came on and we had a talk with him and we kind of went a little bit spiritual. Like I go with light because light is a spiritual thing.
Yeah.
It's a lot of part. It's a big part of a big part of physics we don't fully understand. And I think coming to understand what light is and how it works will solve a lot of problems.
I don't disagree with that.
Yeah. Like, growth problems, energy problems, health problems, circadian, like coming to understand light. Is working in LEDs, is that coming to understand light, or is it just an after effect of electronics? And honing it, you're not really understanding light. You're just kind of honing the light or something.
I mean, I think it enables us to be able to understand it better, right? LEDs being that they are such a narrow emission, so you can create things that are very narrow in the wavelength. It gives you that ability to custom design however you want that output to actually physically look like. So when you were talking incandescent bulbs or fluorescent tubes, you kind of had a static output, and you couldn't really actually study the different effects on a human body based off certain wavelengths. We didn't have anything that could do that. The lasers came out before, high power LEDs, but you're not going to shine a laser at someone and find out what happens, right? It's just not going to work.
Sure.
So being able to effectively irradiate, and I know that sounds kind of like a dangerous word, but
sure.
I mean, the radiation of the light,
that's what light is.
It is radiation, right? So if you can irradiate a person, a plant, anything in a certain way, you can kind of start to study what those effects actually do. If you change, I'm going to put more blue in here and see how that affects a person, or less blue and see how that affects, or more red, or anything. So yeah, I mean, we're now enabled to do all this stuff that we just could not do before, because you heat up an element, and it emits light, and that's what it was. You couldn't really adjust it.
Yes, and I think now we see a lot of like there's whole, and we talked to Dr. Matson about this. There's not a new institution, but new segments and new specialities are being formed around the science of light. And we had, I don't know if you know who Jennifer Veach is, Dr. Jennifer Veach.
The name sounds familiar.
She's a lighting, another one of these scientists that's in this movement of integrative lighting, or whatever they want to call it. And the fact is that we're really learning a lot about light, and this translates into the ground, into horticulture. Right?
Yep.
What is OSRAM doing in the horticultural space? Since we're at HortiCann Tech Light, what are you guys doing there that's really innovative?
So we're trying to provide basically any LED you would ever possibly need to do that. And by doing so, we're trying to make the best package we can possibly do. So we've got some very, very high efficient products, industry leading ones, especially in the hyper red range, where we know there's a lot of effects from that 660 nanometer when it comes to plant growth.
So darky, but
I mean, it's a nerdy industry, right?
Sure.
But we're just trying to enable anybody and everybody to be able to understand the industry and then be able to make the best product that could possibly be, because we understand, obviously the cannabis market, that's where there's a lot of money. So obviously that's what's going to help proliferate lighting into crop growth. But obviously the far reaching aspect of being able to maybe solve world hunger, because you can grow anything anywhere with these lights and things like that. I mean, it's a huge thing, and I think it's going to benefit, the world. And we want to be able to enable that as best as we can.
Yeah, I mean, so you take it from those big goals, like from a corporate perspective, we know it's about the dollar bills, right?
Of course.
But also you look at, like, there's real problems,
Yeah,
right? It's like, can we produce enough food? Do we need another green revolution if we hit 9 billion people? Like, these are all real questions, right? What's the carbon intensity of inside growing versus growing in fields? What plants can be moved inside? Like when you saw Dr. Matson's show about the field, greenhouse, LED, HPS, and you see the yields are going up on the LED side. Are you guys helping your customers implement these new systems you've created into their fixtures? You help with the fixture design? What are you guys doing?
We can. I mean, a lot of it depends on what aspect of lighting design that customer is lacking. If they fully understand LEDs and how you control them, how you drive them, how you manage their heat, how you control how the light is extracted, we don't really have to get too involved, other than making sure we get them the best and brightest of the product we have. But there are a lot of lighting manufacturers out there that were used to just bending metal and putting a bulb in there, right? I mean, it's a completely different market. So
fluorescent fixture market was a sheet metal game.
Exactly. You were metal benders.
You put a sheet metal in, you grab some sheet metal, you throw ballast in, and you're not really a manufacturer. Come on, man.
Yeah, exactly.
Like, come on. I mean, when you used to hear like fluorescent fixture manufacturer, you go, really? Really?
We've been to a couple factories. What I see is the people that put it together, there's a roll of LEDs on a roll, right?
On a reel. Yep.
Are you guys actually putting it on metal for people so that it's...
So we are starting to offer that, because we do see that as sometimes that's a value add for certain customers.
Okay.
Our primary business is just selling that reel of LEDs to them and let them figure out, who's going to do the manufacturing. But obviously, since they used to just literally bend metal, stick the bulb in the ballast in and call it a day, now they're like, oh crap, how do I use this LED? How do I design a printed circuit board? How do I do all this? And those are all things that we offer free of charge to our customers as well, because the better we help them use our LEDs, the better our LEDs look, right? If a lot of people out there aren't using them properly, it makes us look bad too, because they're like, oh man, these LEDs, they just don't grow. They're failing and all that kind of stuff. And that comes back to us, even though, well, the LED is fine. It just wasn't designed properly. So we will get as involved as the customer wants us to get involved and help them try to create everything that they can do at the best of their ability.
And drivers don't matter, right? You can use multiple drivers with your LED chips.
Exactly. Yeah, you just have to make sure that you're matching the current that the power supply will output. Obviously, if you drive an LED too hard, they will fail. Sometimes quickly, sometimes they'll take a while, sometimes it's spectacular failures, and other times it's just all of a sudden it just stopped working. So.
Sure. Is there one component of, we go back to this graph that makes a quality LED versus not? Is it the lens? Is it the encapsulation?
It's chip? All of that, because all of that together kind of is what makes an LED an LED.
Okay.
you start at the packaging material, right? There's several different types of packaging materials you'll see. Traditionally, wow, my English is bad. Traditionally, you'll see people using ceramic materials. They're very robust. They stand up to everything. They're pretty deep. They're pretty good at transferring heat out of the back of that chip down into a printed circuit board. Nowadays, especially with lower cost products, you're seeing a lot more plastics and enhanced plastics. So EMC is a name you'll hear. It stands for enhanced molded compound. It's usually kind of like a hybrid between ceramic and plastic. It's a much lower cost. Ceramic's not cheap. You'll also see some cheaper plastics being used, whether it's PCT or even PPA. Those materials don't tend to last as long, especially when put into environments like horticulture, where you've got a lot of other chemicals, you got temperatures, you got a lot of things going on that those can't stand up to. So that's one thing that I think customers need to look at when they are looking at LEDs is not just performance.
Environments affect the life of lighting systems?
Absolutely, right?
Everywhere's the same, right?
Yeah, because one of the
you think
worst
of high heat, high moisture. You're gonna have maybe chemicals and fertilizer. Who knows? You're gonna have in there.
Sulfur is a real bad thing because a lot of times you'll have silver that's exposed inside of that chip, and sulfur and silver don't mix. Right? It ends up getting brown, and you are anticipating light to bounce off that internally, and if that's brown and it's not bouncing off, the light decreases over time, right? And then eventually it can also corrode the wire bonds and things like that. When those fail, they break, no more light, right? So that's one thing that customers need to look at. So it's not just purely, how many lumens does it come out or how many photons come out, but what exactly is that chip made out of? There's different structures for the chip as well, whether it's surface emitting, volume emitting. A lot of times those aren't really as important depending on the type of application you're using. The phosphors, that's a big thing too, because a lot of
the phosphor is put on top of this growing crystal, right?
Yeah,
and that's what gives it the colors,
right? So
that's part of that growth mix secret sauce thing.
The phosphor's not, but there is some secret science behind the chemicals that are used in your phosphors. But what you're effectively trying to do is you can't make white. An LED is a single wavelength or relatively single wavelength. That they're very narrow, but so you can't create white light. What you have to do is you have to you take those blue photons and hit a yellow phosphor and excite these lower or longer wavelength colors. So greens, ambers, reds, yellows, all that. And when all of that combined, it looks white to the human eye. So there's a lot of science behind the mix going behind that. And that's a lot of the efficacies and whatnot that you see out there is based off of how good those phosphors are, how the chemicals that are used inside of those. You don't typically see that too many phosphors being used in horticulture other than obviously the white LEDs. You're not usually seeing any of the other colors being made out of phosphors because there are some losses of efficacy light-wise. They're not as bright when you're trying to do that purely.
What are you getting for maximum lumens per watt right now out of an LED chip?
For whites, you're seeing a lot of 215, 220 to 25 lumens per watt at bidding conditions.
But then usable.
I mean, obviously that's going to be at like 25C at a bidding condition. In the real world, you're usually going to lose. You're not going to be at 25C, right? You're going to be warmer than that, so you're going to lose some light there, and then usually you're going to have some kind of electrical loss to your power supply. You're gonna, if you have an optic or some kind of lens over, you're gonna lose that too. So you can pretty much expect to lose maybe 85% when you actually throw something into a design.
And is it gonna ever get higher than that 220?
I mean, the science says yes, it can be. There is a theoretical max. I can't remember off the top of my head what it is.
300.
Yeah, something around there, because it's based off of how our eyes see light. You could make a single wavelength green LED to be 683 lumens per watt, but it's green. I mean, if you really want to walk around and be, right, because our eyes are super sensitive to green. So there is an absolute theoretical max that if I can convert 100% of my electricity into photons to make a certain color of light, that is the theoretical max. That you can't be bright, you can't be more luminous.
What's the sun's lumens per watt?
I don't know. Well, I'm going to say it's infinite since it doesn't use any of our electricity, right?
There you go.
No, there's a wattage to the sun for sure. It's a nuclear fission reactor.
I mean,
If that's what it is, it's a nuclear fission reactor or fusion, one of the two.
You're right.
It's a fission reactor.
You could probably calculate the amount of energy that thing is outputting versus how much of it is
light.
Yeah.
I want to know what the lumens per watt
right now
is right
now.
Kurt, you're off the show.
Hold on.
You're off the show.
I got this Google thing in my pocket that might be able to help.
There you go.
So you're a chemical engineer?
No, I'm an electrical engineer.
Electrical engineer. So is it a combination of chemical and electrical engineers at OSRAM? It sounds like a lot of chemistry.
It depends on what level into the company. So I'm more of a so I'm an applications engineer. So I'm kind of a sales support type person.
You're helping people build fixtures.
Exactly. I'm helping. I go with our sales, our force, and our marketing team to kind of help our customers understand how they should use the LED, how it can be used, maybe come up with new ideas that they hadn't thought of originally. The team is primarily like electrical or mechanical engineers, because really the most important things to consider when you're designing with an LED is the electricity going through it, right? The current drive and all that, managing the thermal, the temperatures and all that, and then how to control the light. So kind of an optical. So those are kind of the three main things that you have to focus on.
There you go. Secret sauce of LED chips.
Kurt, there you go. Thanks for coming on the show. It's osram.com/os for the semiconductors division, right?
Yep, absolutely.
And you guys are out of Michigan.
We're out of all over the place. So we have a sales office in the Metro Detroit area. Okay. We also have one in the Sunnyvale area as well. Our manufacturing is done in both Penang, Malaysia, as well as Regensburg, Germany.
And you keep stock in the U.S.?
We do not keep stock in the U.S. Some of our we do, but for the most part, it is direct out of the plant.
Okay, so it's made to order. Thank you for coming on the show,
Kurt. My pleasure.
Leipmann, Kurt Leipmann from OSRAM. He is an applications engineer, folks out there listening right now. Thank you for listening. And, of course, go to our sponsor, KeystoneTech.com. Greg.
Check them out.
Go to KeystoneTech.com, Greg. That's KeystoneTech.com. Light made easy. Retrofit Kings.
Thank you.
Thank you. Perfect.